Hi all, welcome to today's session. So in today's session we'll be dealing with QR solution method. So this QR solution method is mainly used to solve least square problems and also the system of linear equations. And suppose you are given with the system Ax is equal to B, where A is some m by n matrix where m greater than n. Then instead of solving directly, what we do, we'll just decompose this A into two matrices, which is Q and R. So this Q will be an orthogonal matrix, and the definition of the orthogonal matrix, as you know, it is Q transpose Q is equal to Q transpose is equal to identity matrix. And you will also have this R, and this R is an upper triangular matrix. We'll just see how we do the problem, and then these things will be more clear. And now when coming to the first question, we are asked to find the least square solution of the system Ax equal to B using the QR method. You are given with your A and also you are given with the B. Okay, so the first step to do this method is, we'll just choose the first column to be A1. Okay, the first column of A is named as A1 and the second column of A is named as A2. Okay, then we find the norm of A1. Norm of A1 is equal to root of sum of the squares of the entry, which is one. First column was 1 1 1, so we'll take root of 1 square plus 1 square plus 1 square, which is root 3, and we'll just form q1, where q1 is given by a1 by norm of a1, that is 1 by root 3 into this a1. A1 was 1 1 1, so basically your q1 will be 1 by root 3, 1 by root 3, 1 by root 3. Now you will just similarly find q2, but here what we do is, we'll just remove the component along q1. For that, to get u2, you have to subtract q1 transpose a2 into q1 from a2. Okay, this is a method. You'll have to learn this formula, where you have a2 u2 is equal to a2 minus q1 transpose a2 into q1. So first we'll just find what is q1 transpose a2, and q1 transpose a2 is given by, you know that q1 transpose is equal to, you can just verify from the previous slide what was q1 and take the transpose and just multiply it with a2, and you will have 1 by root 3 into 1 minus 1 plus 2, which is 2 by root 3. You will have such a constant. Okay, this particular term will be a constant, q1 transpose into a2. Now what we'll do, we'll just multiply it by q1. Your q1 was 2, like 1 by root 3 1 1 1 is, yeah. So multiplying that and taking your a2 minus your q1 transpose e2, which is 2 by root 3 into q1, that is 1 by root 3 into 1 1 1. So on doing this, this particular constant will be 2 by 3, and taking it to the inside, you have first term as 1 minus 2 by 3 into 1, which is 1 minus 2 by 3, that is 1 by 3. You have 1 by 3 here. Here you have minus 1 minus 2 by 3, which is minus 5 by 3. Here you have 2 minus 2 by 3, which is 4 by 3. And you have, this is your u2. Okay, you found what is q1, and now you have u2, and we will take the norm of u2. How will we do the norm of u2? We'll just take 1 by 3 the whole square plus 5 by 3 the whole square plus 4 by 3 the whole square. So the denominator is 3 square, so it's 9. And numerator will be 1 plus 25 plus 16, and on taking the root, you have root 42 by 3. And on dividing this u2 by this norm of u2, you have q2. Okay, so for that you will just do you will multiply each and every term by root 42 by 3. So first term 1 by 3, here 1 by 3 into root 42 by 3 will be root 42. So sorry, it's not multiplication, it's division. Okay, it's u2. It's basically what you do is u2 divided by norm of u2. Okay, I'm sorry about this. Yeah, norm of u2. So on doing that, you have u2 is 1 by 3, and when 1 by 3 is divided by root 42 by 3, 3 and 3 will be cancelled, you will be having 1 by 42. Okay, and in the next term, minus 5 by 3 divided by root 42 by 3, 3 and 3 will be cancelled, so you'll have minus 5 by root 42. And similarly you can do, you will find q2, and after getting q2, you can find q. You have the orthogonal matrix q. What is q? Your first column will be the q1, and the second entry will be q2. Okay, by entering q1 and q2, you have q. And now to get R, you can just take the Q transpose and then multiply by the given matrix A. Take the transpose of this matrix, which will be 1 by root 3, 1 by root 3, 1 by root 3, 1 by root 4 by 2, minus 5 by root 4 by 2, 4 by 4 root 2. Okay, that will be a 2 by 3 matrix. And taking U transpose into A, you will be having a 2 by 2 matrix, which is root 3 0, 2 by root 3, root 42 by 3. This will be our particular R. And now you have Q and R. And now what you do is, we'll just solve for Rx is equal to Q transpose B. We need to solve for this. So first we need what is Q transpose into B. We had Q, and now also we had B was given with you in the question. So just calculate what is Q transpose B. So on calculating, you will have 11 by root 3 and 14 by root 42. So you have Q transpose B, and now equate Rx is equal to Q transpose B. So on equating Rx is equal to Q transpose B, you can see this matrix is an upper triangular matrix. So this it will be easy for you to compare from the lowest row. So here it's R2, choose R2. So what happens, this into this, 0 into x1, that is 0. So this will basically be root 42 by 3 into x2 is equal to 14 by root 42. You'll have this term. From here you will have x2 is equal to x2 is equal to 42, and 42 will be cancelled, and you will have 14 into 3, which is 42. So both will be cancelled, and your x2 will be equal to 1. Okay, so your x2 is 1, and if x2 is equal to 1, go for the first equation, which is root 3x1 plus 2x1 by root 3 equal to, it was first row in this column, so that will be equal to 11 by root 3. And on equating that, you have this equation, and substituting the value of x2 is equal to 1, you can solve for x1, which is x1 is equal to 3. So you have your x1 and your x2, and hence you have the solution. Okay, hope the method of QI solution is clear. So what you will have to do is, you will have to find Q, and you will have to find R, then you will have to solve for Rx is equal to Q transpose B. Okay, and then you will have the solution. We'll just see one more problem, and here the question is in a different way. Okay, you are asked to fit a straight line y is equal to x plus b to the following data using the QR decomposition method. Okay, so you have x and y, here it is given, so we need to use the least square method. This is your question, and what you can do is, you can get the, okay, so get the matrix, and for the matrix you will have to need, where you were given with the values, when x is equal to 1 your y was equal to 2, and when x is equal to 2 your y was equal to 2, and when x is equal to 3 your y is equal to 4. Okay, so now you need to form this in matrix. Before that, you just apply, when x is equal to 1 your y is 2. So what is your equation? Your equation just apply here. So your, this will be 2 is equal to uh, a into 1 plus b, so which is a plus b, right? So on converting this into a matrix form, coefficient of a is 1, coefficient of b is 1, and that into ab will give you first entries 2. Hope you got it. Here the coefficient is 1, here the coefficient is 1, so you will have this one entry, and you have the AB here, and then your first entry will be 2. Now similarly substitute 2 here, and also here also you have 2. So when going with the matrix, you have here 2 and here 1, so that your the entries will be 2 and 1, and y value is equal to 2, so you have here b is equal to 2. And now for the third value, just substitute y is equal to 4 and x is equal to 3. So that will be 3 and 1, and your b will be equal to 4. Okay, in this way you can just convert this given equation into a matrix form. Okay, so after you have the matrix, we can just take the columns of a1. So it will be 1 2 3, your a2 is 1 1 1. Now what we do, we'll just find the norm of a1. First column we'll just find the norm, and then divide it with the a1, and hence you have q1. Now to find q2, you need to remember that formula. First, your u2 was equal to a2 minus q1 transpose a2 into q1. Okay, so for that, first you will just find what is q1 transpose into e2. So on doing q1 transpose into e2, you will be having a constant here at 6 by 14 root 14. Okay, and now this particular value into your q1 will be your projection of a2, and then you'll have to subtract it from your a2. A2 is the second column of a, and then on doing the subtraction you have your u2 is equal to this particular value, 4 by 7, 1 by 7, minus 2 by root 7, sorry, minus 2 by 7. And now to get q2 you will have to divide it by the norm of this one. What will be the norm? Norm will be root of 4 square, which is 16, 16 plus 1 plus 4, which is 16 plus 5, that is 21, and you'll have to take the root, then you have root 21 by root 49, right, which is 7. So you have your norm of u2 is equal to this one, and then divide each and every term by this, so that will be 4 by root 21, 1 by root 21, and minus 2 by root 21. This is your q2. And after having your q2 you can just form the q by this will be your q1, this is your q2, and you have q. And now you'll have to find r. How will you find the r? Just take q transpose a and you have r. Okay, now you will solve for the equation rx is equal to q transpose b. So before that just find q transpose b also. Okay, to get r you will have to do q transpose a, and to get, you just find q transpose b there itself, and hence by finding q transpose b your value will be this, and on solving this, writing it in the matrix form, you will have rx is equal to q transpose. This will be an upper triangular matrix, and on comparing the lowest row you'll be having root 21 by 7, b equal to 2 by root 21, and on solving that your b will be equal to, just take this 21 to here, so that will be 7 by root 21, so it will be 14 by 21. On cancelling by 7 it would be 2 by 3. Okay, so you have your b is equal to 2 by 3, and just substitute your b in the first row to get the value of a, and you have the value of a also, and you have a and b. Your equation was y is equal to ax plus b, so it would be y is equal to 1x plus 2 by 3. So this is the way you fit the curve, y is equal to x plus 2 by 3. Okay.